In section 2.4, we want to evaluate indeterminate forms of type plus infinity minus plus infinity and minus infinity minus infinity. The goal is to evaluate limits of types. I'm going to list more. It's anything, any two infinity that look like you can cancel them. So the two I've just wrote would work, but anything that's close to this. So let me show you a few more. If you have plus infinity and you add minus infinity, that would also be indeterminate. Really, it's this one, but I just flipped the sign. So you have a bunch of them. If I start with minus infinity, I could add plus infinity. All right. It's not true that any combination would be indeterminate. So for example, if I have plus infinity plus plus infinity, that's a huge number plus a huge number. It's a huger number, but it's still huge. And so that would just be plus infinity. All right, so if you encounter a limit, you evaluate it and you get this, you don't need to do L'Hopital's rule. You know it's plus infinity and you move on. So for this section, it's only going to be the combination that could cancel. Those are the ones that are indeterminate. So here's the method. We want to use what we've learned in the last two sections in 2.2 and 2.3. So we want to use algebra or something to transform the limits into 0 over 0 or infinity over infinity. In that case, we would apply L'Hopital directly, or 0 times infinity. And in that case, we'll use a method that we just learned. We would take one of the two factors down. All right, there are different methods that you can take to transform them into that. It depends on what type of functions you have. All right, if you have something in common, you would factor it out. So factor common terms. Put over common denominator. If you have fractions, that's good. If you have polynomials, probably going to be this. And then use the laws of logarithm, well, only if you have logs, but if you have a difference of two logs, then you could write it as a log of a fraction, and then this fraction, you could probably look at it separately and maybe use L'Hopital here. All right, let's try this one. I want to evaluate the following limits. It's a limit as x goes to infinity of log of 2x minus log of 2x plus 1. All right, so if I plug it in, I get log of infinity minus logarithm of infinity. I keep swearing it's my last time. All right, I just think it's so important to know this graph. All right, infinity is that way, so we're going up to positive infinity. So both are positive infinity. They look like they could cancel. It's a huge term minus a huge term, so it could be different things. If the first term is bigger, it could be big. If the second term is bigger, it could be very negative. And if they're about the same, it could be 0, it could be 1. So it could turn out to be any value. All right, so I need to put them together somehow. The method that would use, I mean, I don't have anything in common, so that doesn't work. I don't have fractions, so common denominator is irrelevant. But laws of log, oh yeah, I have logs here. So I'm going to get the limit as x goes to positive infinity, log of 2x over 2x plus 1. All right, perfect. Let's look at the interior separately. I have the limit as x goes to positive infinity, 2x over 2x plus 1. You could either factor out the x or use L'Hopital. Let me use L'Hopital just because it's in the L'Hopital section. I get 2 over 2, and so the limit would be 1. That's the interior. And so if I use the fact that log is continuous, I can switch them. And then I would get log of 1, which is 0. All right, not so bad.